In today's world, precision is paramount. From the smartphones we carry to the airplanes we fly in, our demand for increasingly complex and accurate products continues to grow. This demand drives the manufacturing industry towards ever more precise and efficient technologies. Traditional machining methods, while effective, often struggle to keep pace with these evolving needs. Cutting, drilling, and milling rely on mechanical force, which can limit the intricacy and accuracy achievable, especially with hard or delicate materials. This is where electric discharge machining, or EDM, emerges as a game changer. EDM represents a paradigm shift in manufacturing, offering unparalleled precision and versatility. By harnessing the power of electrical discharges, EDM opens doors to creating parts that were once considered impossible. Electric discharge machining, often referred to as spark machining, is a non-traditional manufacturing process that uses controlled electrical discharges to remove material from a workpiece. Unlike conventional machining methods, EDM does not rely on mechanical force or cutting tools. Instead, it utilizes a series of rapid, controlled sparks to erode material with incredible precision. These sparks occur in a small gap between an electrode, which is usually made of copper or graphite, and the workpiece itself. This unique approach offers significant advantages, particularly when working with hard metals, intricate designs, and extremely tight tolerances. EDM's ability to precisely remove material without physical contact makes it ideal for a wide range of applications where traditional machining falls short. The magic of EDM lies in the controlled application of electrical discharges. The process takes place within a dielectric fluid bath, typically deionized water or oil, which serves several critical functions. First, the dielectric fluid acts as an insulator, preventing current from flowing randomly between the electrode and the workpiece. However, when the gap between them becomes sufficiently small, the dielectric fluid breaks down, creating a conductive channel. This breakdown allows a spark to jump the gap, generating intense heat localized at the point of discharge. This heat vaporizes a tiny amount of material from the workpiece, creating a small crater. By controlling the frequency, intensity, and duration of these sparks, EDM can precisely erode material with remarkable accuracy. Section 4. Sinker EDM, Shaping with Submerged Sparks. There are two main types of EDM, sinker EDM and wire EDM. Sinker EDM, also known as ram EDM, uses a pre-shaped electrode that is gradually lowered into the workpiece, submerged in the dielectric fluid. As the electrode approaches the workpiece, sparks occur in the gap, eroding material and replicating the inverse shape of the electrode onto the workpiece. This process is highly controlled, allowing for the creation of complex cavities, intricate details, and precise shapes. Sinker EDM excels in applications requiring deep, intricate cavities such as mold making, die sinking, and the creation of complex internal features. The ability to accurately reproduce complex geometries makes it an invaluable tool in industries like aerospace, automotive, and medical device manufacturing. Section 5. Wire EDM, Cutting with a Hair-Thin Electrode. Wire EDM, as the name suggests, utilizes a thin, continuously fed wire as the electrode. This wire, typically made of brass or molybdenum, is threaded through the workpiece, which is also submerged in dielectric fluid. As the wire moves along a programmed path, sparks occur between the wire and the workpiece, eroding material and cutting through it with exceptional precision. The continuous feeding of fresh wire ensures a consistently sharp cutting edge, enabling intricate cuts and extremely fine details. Wire EDM is particularly well suited for cutting complex shapes, intricate contours, and delicate features in a wide range of materials. Its ability to create extremely fine cuts with minimal material removal makes it ideal for applications like medical implants, micro machining, and the production of delicate components.